I've heard from various flat earthers that looking up at the sky does not tell you anything about the shape of the earth. So for this video, let's talk about maps. More importantly, we'll talk about why it is that the flat earth movement does not have a useful map. Sure, there's this thing which a lot of flat earthers show, but you can't use it to get distances between features on the map which correspond with distances in the real world. This is arguably the main point of most maps. Wikipedia has this little article, and in the usual fashion there's a summary at the top and loads of details further down. Link is in the description and I highly recommend you read it. A map is a symbolic description of interrelationships, commonly spatial, between things within a space. So here's a map from Google Maps of my neighborhood. I can easily verify that this map is accurate because I can measure the distance between things on the map, apply the scale, and then go measure those things in reality. If the distances line up, then the map is accurate. Google Maps is trusted by millions of people because of its accuracy. Everybody I know uses Google's navigational tools all the time. How many complaints have you ever heard about somebody claiming the distance displayed in Google Maps is wrong? Even more amazing than Google Maps is Google Earth. It is a 1-to-1 scale representation of the Earth. You can access this creation from an app or by visiting earth.google.com in Chrome on your browser. In the Pro version of this app, you have some really cool tools to play with this dataset. I'll be using Google Earth until anyone can show me a physical measurement that they did on the real Earth that did not correspond with the same measurement done on Google Earth. For small scales, it is easy to represent what you are measuring on a flat piece of paper. So if you are making a map of your house, your neighborhood, or even the county you are in, you can take measurements and scale them down and then mark up the features on a map, which is then useful for navigating that area on the map. If the Earth was flat and you were trying to represent it on a flat piece of paper, this would be quite forward to map out the whole Earth on a flat piece of paper. And so it is quite telling that no accurate map of the flat Earth exists. The earliest map makers did run into a problem when they started being both more accurate and the maps are getting bigger. The numbers just did not add up. So it is very definitely a question of scale. Here is another Wikipedia article that has more information on scale and how it relates to map making. So here we go, scale map. If the region of the map is small enough to ignore Earth's curvature, such as a town plan, then a single value can be used as the scale without causing measurement errors. In maps covering larger areas or the whole Earth, the map scale may be less useful or even useless in measuring distances. So this is what we're talking about flat maps, yeah? So we can scroll a little bit further, and then here is a really interesting article segment of the article. The region over which the Earth can be regarded as flat depends on the accuracy of the survey measurements. If measured only to the nearest meter, then the curvature of Earth is undetectable over a meridian distance of about 100 kilometers or 62 miles and over an east-west line of about 80 kilometers. If surveyed to the nearest millimeter, then the curvature is undetectable over a meridian of about 10 kilometers and over an east-west line of about 8 kilometers. So this is why the flat earthers have such a lot of trouble finding the curvatures, because they're just not looking large enough. The Earth is really, really big, and it's quite difficult to get your head wrapped around in it. So to show you the issues, let's open my copy of Earth, and this is my neighborhood here. This is where I live. Let's just tap that open. So if I take a ruler and say from the corner of that past my house to the corner of that, 513 meters, yeah? So this one-to-one representation in Google Earth is a picture taken from Airbus, I believe, so from an aeroplane, and it's been scaled correctly. So I can go to that corner of that and pace out this thing, and when I get there, it's going to be 513 meters. So because this is so small, my hometown is only small. Let's just flatten that up, just from straight up. There we go, nice little desert town. That's the whole town. It's not very big. I mean, from side to side, we're looking at 7-8 kilometers. So the scale of this, you're not going to see any errors because the Earth is so big. I mean, if you were just looking around on this thing, and let's just look at the horizon from here, eye altitude at 1 kilometer, I can see a mountain there in the difference, and it doesn't look like the Earth is curved at all. And then that's almost 1 kilometer up already. I mean, you've got to line up the horizon with something that is really straight, and then you can see, oh, the land is a little bit higher, the ocean is over there. So yeah, you can turn it here, and with the eye altitude of a couple of meters, you'd be hard pressed to see the curvature, which is why most flat earthers say, there's no curvature. However, you stick it up to the height of an aeroplane, a bit higher than an aeroplane would fly, so it still looks pretty flat there, but once you put it to something straight, my screen edge there, you can see there's a definite curvature. This is approximates what I see from space anyway. So yeah, this looks like a really accurate map. There's a distance that I drove last year sometime, and you can see 1,390 kilometers. It's a fair distance, over this sort of distance you'd start seeing the effect of the Earth, and you can see it's a little bit of a squirrely map. But if I do a straight line across, that's 11 kilometers. If we stick it in miles for the American watchers, that's about 700 miles. So around about that range, things start getting weird. Yeah. So let's get back to our map making friends, just to give you an idea of where that scale comes from. So where's London again? Alright, so let's say somebody's making a map and they says, well, I'm going to make a map that is 1,000 kilometers by 1,000 kilometers. That's the size of the map I'm going to make. So obviously he'll take his compass and start from London and just go south until, I don't want miles, I want kilometers, like a proper person. And we'll just stay next to that line, and that's near enough. So we'll mark our positions. I'll say that's our starting position. Call it start, and then that's okay. I'll drag another little pin down, and then it's just at the end there. You can zoom in for some accuracy. So this map maker did his first 1,000 kilometers, and now using his compass he turns east. So now it's going to do 1,000 kilometers to the east. So let's just grab that line, and that's about east. We'll just get the same distances there. Yeah, close enough. And you can make this hyper accurate, but I'm not going to do that. You'll see the error without being hyper accurate, which is sort of the whole point here. So that was 1,000 kilometers. I will go up again somewhere here in Germany. There you go. Put another little place mark there. We'll stick that on the end. And now we'll say that's good. And now I'll just draw straight east. So going through the same place again, London, and 1,000 kilometers, you see it overshoots it a bit. And by a bit I mean a lot. So just to give you an idea, we'll zoom in. So that's Bath, from London to Bath. I mean, if this guy came back with his map, and what's that in kilometers? Bath to London, 160 kilometers. If somebody came to you and says, my map is 160 kilometers inaccurate, you wouldn't buy his map. You'd call it a bit of a shitty map, actually. So obviously the error there is that the compass is pointing towards the North Pole, and as you go around the Earth, around the curvature of the Earth, the further south you are, the further away each line is, you know. So to put it in a different way, any 2 points on Earth, any 2 points, if you start at those 2 points and you start walking north, you're going to meet up, yeah. Every line, if you keep on going north, you're going to end up in the North Pole. So obviously the map sort of tapers off to the top, and you'd think, okay, yeah, now, you know, there's obviously, if the Earth is flat and the lines just radiate out forever, you'd be able to just take this into account. However, you know, with a flat Earth model, the entire southern hemisphere is a problem, because you can go to South Africa, you can go here. Let's just pick a little town, any little town. But yeah, let's say you go to Vredendal, all right? Stick a little marker up there, Vredendal, just so we don't lose it. And whip out the ruler again, and you drive 1,000. No, you drive 1,000 kilometers to this funky little place, yeah? So you can do that in South Africa because it's a big place. Now you do your north 1,000. Still in South Africa, by the way. Really funky. Alright. And then from there you do your 1,000, and you might just hit Namibia. Yeah. And for the little mini shot, you go down, and yeah, there is quite a big difference. And I mean, we can mark this thing again. Put our untitled place mark there, and just, I mean, I've measured really quickly here, but now it's gone the opposite way. 83 kilometers the wrong way. Now your line at the top was 83 kilometers longer than the line at the bottom. How does that work? How does that work? I mean, the only way that works is if beyond the equator they converge again onto Antarctica. So yeah, millions of people use Google Earth, they use the database, even the flat earthers use the Google Earth, and here you can see Earth in all of its glory. That's a copy of Earth, cheap copy, but accurate enough for our users. So yeah, if a flat earther ever tells you globe is impossible, tell them, give me a map. Give me a map of a flat earth that I can measure a distance on, apply a scale that's the same everywhere, and map that to Earth. They can't do it. The Earth is a globe. That's just a fact. So thanks for watching. Goodbye.